Pork is the most heavily consumed red meat on the planet, found in the recipes of countless global cuisines. For centuries, preparing and selling cuts of domestic pig has been a cornerstone of local agriculture and commerce. But a raw cut of pork carries distinct biological threats that separate it from other common proteins like beef or lamb. In many developing nations, or when sourced from wild populations, undercooked pork acts as a carrier for microscopic parasites. The most notorious is Taenia solium, the pork tapeworm, which can live in the human intestinal tract if ingested. In severe cases, this parasite causes cysticercosis, a dangerous condition recognized as a leading cause of acquired epilepsy worldwide. There is also a microscopic protozoan known as Toxoplasma gondii. In people with weakened immune systems, it rapidly invades and multiplies inside human cells, causing severe systemic illness. In its raw state, pork remains a reservoir for these pathogens. Without specific human intervention, it is an active hazard to our biology. Applying intense heat forces the biological structure of the meat to change. Once the internal temperature climbs high enough to neutralize those parasitic threats, the meat reaches a state of high nutritional density. Take a look at this chart comparing common protein sources. When we measure the protein percentage of cooked lean pork by dry weight, it reaches 89%. That density provides all 9 essential amino acids the human body requires for cellular growth and repair. Crossing this thermal threshold yields a concentrated source of muscle-repairing nutrients for athletes and post-surgery patients. Beyond protein, pork holds a dense payload of bioactive compounds. It carries unusually high levels of thiamine compared to beef and lamb. It also provides a heavy dose of beta-alanine, which our bodies use to produce a compound called carnosine. Higher carnosine levels in human muscles actively reduce fatigue and increase athletic endurance. This combination of protein and carnosine production is critical for older adults fighting sarcopenia, the gradual loss of muscle mass over time. Yet public perception often links this meat directly to heart disease, driven by concerns over its fat content. However, data shows that these links are often skewed by highly processed products and broad lifestyle factors rather than the meat itself. Lean pork provides the building blocks for muscle growth and maintenance, without the cardiovascular risks found in processed variants like bacon. But pushing the heat too far creates new risks. Excessive temperatures turn the food into a chemical liability. Exposing animal proteins to the extreme heat of grilling or barbecuing triggers a molecular reaction. As this schematic illustrates, the proteins mutate into heterocyclic amines, or HCAs. These compounds accumulate in the blackened, well-done exterior crusts of the meat. High intake of HCAs is linked to an increased risk of several serious illnesses, including colon, breast, and prostate cancers. Leaving the cut over the fire for too long burns away the nutritional benefits, replacing them with carcinogenic hazards. The final health impact of pork is not fixed. It changes based on how the meat is handled. First, you must cook it thoroughly enough to reach the thermal threshold that neutralizes parasites. Second, you have to pull it away from the fire before the exterior chars and generates carcinogens. Ultimately, the nutritional value of pork is defined by the specific temperatures we choose to apply.